So let's look at this example here. In the year 2000, the population of the world was 6.070 billion. In the year 2015, it was 7.3 billion. Use this information to create a model in the form y equals a e to the power of RT, where y represents the population in billions and t is the time in years since the year 2000. Assuming a model of exponential growth, estimate the global population in 2020, 2050. When will the world population reach 10 billion? So before we worry about answering A, B, or C here, we first of all need to create the model. So we know the model will take the form y equals a e to the power of RT. And looking at the question, we have, let's write down this information. In the year 2000, the population was 6.070 billion. So in the year 2000, y representing the population is 6.070. And in the year 2015, the population was 7.3 billion. Okay, so in the year 2015, the population is 7.3. Now these are in billions. That's 6.070 billion and 7.3 billion. All right, so my advice to you is you always want to start at time zero. So the year 2000, when the population is 6.07 billion, that is going to be when t equals 0. And the year 2015, when the population is 7.3 billion, that is going to be when t is equals to 15. So to simplify the situation for ourselves, we should always label the starting year, whatever year we start investigating the process at, as our t0, and then every year on from that we can figure out. So 2015, when t equals 15. All right, so going back to the function, y equals a e to the RT. My initial value when t equals 0 is 6.07 billion. So therefore, since we know that a is the initial value, we know we can write the function as y equals 6.07 e to the RT. Remember, because our a is our initial value. We've already looked at that. When we have it as y equals a e to the RT, a is the initial value. So, and remember, we can work that out. If we're not happy to take that, we can just work it out. We have our y equals a e to the RT, and we know that when t is 0, the population is 6.07 billion. So fill in 6.07 in for y equals, and fill in t in for 0. Remember, e to the power 0 is 1. So you end up getting 6.07 is equals to a times 1, which is just a. So this is why a is 6.07 in this case. But as I said to you, a will always be the initial value. So the initial value was 6.07. So that is our value for a. Right, but we still haven't figured out what the value for r is. We weren't told what the growth rate was in the question. We have to figure that out. And we have to use this other piece of information to figure out what the growth rate is. So it's telling us that in the year 2015, in other words, when t is 15, the population had reached 7.3 billion. So what growth rate would lead to a population of 7.3 billion after 15 years? Well, that's what we have to figure out. So let's have a look at the graph of this situation. We want to create a function of the format y equals a e to the RT, where our input is time, more specifically the years since the year 2000, how many years have passed since the year 2000, and our output is going to be the population in billions. Okay? So we know our initial value is 6.07. So we know the function y equals 6.07 e to the RT. So that means we know we can set our a at 6.07. So setting our a at 6.07 will look something like this. But we don't know what the growth rate is. We still have to figure out what the growth rate is. And remember, we have this information here that when t is 15, the population will be 7.3 billion. So we're going to use this to help us figure out the growth rate. So when t is 15, we know that the population is 7.3. All right, in the year 2015, the population is 7.3 billion. So that creates another point, the point 15, 7.3. When t is 15, the population is 7.3. So we now have to figure out what growth rate will give us a function that cuts through that point as well. So we have to adjust the growth rate. So we have, after 15 years, a value of 7.3 billion. So we know our value of A is 6.07, but what growth rate will let us go through this point? What growth rate will give us a value of 7.3 when the input is 15? So we'll have to set up some sort of equation to figure this out. So we have our function so far, y equals 6.07 e to the RT, and we know that y will equal 7.3 when t is equals to 15. So we're going to sub 7.3 in for y and 15 in for t and solve for r. So 7.3 equals 6.07 e to the r times 15. So this is another exponential equation, and this time I have to solve for r. So once again, we will be getting the natural log of both sides, but not until we have divided both sides by 6.07. So my first step, dividing both sides by 6.07, 7.3 divided by 6.07 equals e to the power of 15r. Now I can get the natural log of both sides. So the ln of 7.3 over 6.07 equals the ln of e to the power of 15r. So the ln of 7.3 divided by 6.07 equals simply 15r. So if I continue this up here, we can type the ln of 7.3 divided by 6.07 into our calculator, and you will get 0.1845 is equals to 15r. Then dividing both sides by 15, you will get 0.0123 is equals to r. So now we found our growth rate. So once we know our growth rate, we can complete the function, we can complete the model. So the model that best describes this situation is y equals 6.07 e to the power of 0.0123 t. So this model here, or this function, describes the situation where we have a population of 6.07 at time 0, which was the year 2000, and at time 15, after 15 years, we have a population of 7.3 billion. That is described by the function y equals 6.07 e to the power of 0.0123 t, and you can see that function right here. So now that we know that the function is y equals 6.07 e to the power of 0.0123, we can get back to answering some of the questions. So what were the actual questions? So we've created a model. So now, assuming the model of exponential growth to estimate the population, what is the population going to be in the year 2020? In other words, what will the population be when t is equals to 20? Now this is fairly straightforward. We just have to fill t equals 20 into our function. So we will get y equals 6.07 e to the power 0.0123 times 20. This is the part A. And we can just type this into our calculator, and we will get y is equals to 7.76. And remember, this is in billions, so 7.76 billion will be the predicted population in the year 2020 based on this function. Looking at part B of the question, estimate the population in 2050. So in other words, what will the value of y be when t is equals to 50? So this is fairly straightforward. Similar idea, we have the function y equals 6.07e to the 0.0123, and we want to know what is y when t is equals to 50. So once again, this is just a case of filling in 50 in instead of t. So 6.07e to the 0.0123 times 50. And once again, you can type that into your calculator and you will get y is equals to 11.23. And remember, once again, that is in billions. So that is 11.23 billion. So that is our answer to part B. Okay, what about the part C here? When will the world population reach 10 billion? So in that case, we know that y is going to be 10 for 10 billion, and we have to solve for t this time. We don't know what t is. So y is going to be 10. So taking our function, we have our function once again, y equals 6.07 e to the power of 0.0123t. And this time we know that y is going to be 10 and we have to solve for t. So we sub 10 in for y. So 10 is equals to 6.07 e to the power of 0.0123t. So this is a situation where we're trying to solve for the power of the exponential. So we're going to get the natural log of both sides. But before we do that, we'll divide both sides by 6.07. So 10 over 6.07 equals e to the power of 0.0123t. Then we get the natural log of both sides. So the ln of 10 divided by 6.07 equals the ln of e to the power of 0.0123t. So moving along here, the ln of 10 divided by 6.07 equals, and we know that this right hand side just becomes 0.0123t. Continuing this on, we can type the ln of 10 divided by 6.07 into our calculator, and we will get 0.499226 is equals to 0.0123t. So then 0.499226 divided by 0.0123 will equal to t. And then typing this into our calculator, we will get 40.59, if we round to two decimal places, is equals to t. So it will take 40.59 years for the population to reach 10 billion. That's 40.59 years after the start of the year 2000. So if we look back at the question, when will the world population reach 10 billion? The population will be 10 when t equals 40.59. And if you want to be more specific, during the year, sometime during the year 2040, we predict the population to hit 10 billion. So that is our detailed introduction into the exponential function. The best thing for you guys to do is just to practice these questions to get better. You can check your solutions online. And for access to questions, solutions, graded quizzes and more, visit www.limbymaths.com.